All right, we are expanding and condensing logarithms today, and we're going to learn some properties that go along with those. But first, we need to introduce you to another important value in mathematics, which is the number e. The number e. E is irrational. It's kind of like pi, as in decimal form, it goes on forever and never repeats. But this does come up a lot in population growth and exponential growth and decay. And you'll definitely see e and the logarithm that goes with e more in higher level math. So this is called the natural number, aka Euler's number. I don't believe e was for Euler, but I'm not 100% on that. And its decimal approximation is about 2.718. And again, this has to do with like exponential growth and things at infinity. So if I have a logarithm that uses our new number e as its base, that logarithm is referred to as the natural log. And you can see rather than writing it as log base e, it actually has its own way of writing it, which is ln. Okay, so I believe this comes from Latin, why it's ln instead of nl, but we call it the natural log, ln of x. Okay, so if I do the natural log, and you'll see this in scientific calculators right next to the log key, the natural log of this number e, remember that would mean log base e, the natural log of e. And this is essentially asking you, e to what power is e? E to the first power is e. And so the natural log of e, if we see that, we'll have a value of 1. I think that does come up in one of our examples. Okay, so now we've introduced this new number e and this new logarithm called the natural log that uses e as its base. Let's get into our properties. Okay, so we have 3 properties that we can use to condense or expand logarithms, expressions with logarithms. The first one is called the product rule. And it says if I have 2 logarithms being added together, as long as we have the same base, we can write that as one logarithm and multiply those 2 values, u and v multiplied. Or vice versa, if I take the condensed, if I have things being multiplied, we can write them as 2 things being added together. Okay, likewise, we have a quotient rule, which says if I have 2 logs being subtracted, we can write that as one log where our 2 values are being divided. So think adding, multiply, subtract, divide, right? Makes sense. And this does go in the order of the top minus the bottom. So u would be the value on top, v on bottom. And of course, vice versa. If I have 2 things being divided, we can write them as 2 logarithms being subtracted, depending on if we're trying to condense or expand. Our last one, called the power rule, says if I have an exponent that acts on everything inside of here, you can bring that out as a multiplier in front of your logarithm. So it'd be n times log base b of u. Or if you have a multiplier out here, if you're trying to condense, you bring it in as an exponent. Okay, since we are going to be expanding or condensing, and one of them is like simplifying. So if you're condensing, you're kind of following order of operations. Powers have to do with exponents, multiplication, division. And when we're expanding, we would do those the exact opposite way. It's kind of unsimplifying. So the quotient rule, then the product rule, then the power rule. And this is what we're going to need for our first few examples. Okay, so use the above rules and expand each expression. So the first thing we're going to look for if we're expanding is the quotient rule. And the quotient rule says if I have 2 things being divided, we can write them as 2 logs being subtracted. So do I have anything being divided in here? No. Okay, so we can skip the quotient rule, move on to product rule. Product rule says if I have things being multiplied, we can expand them as individual logs being added. And in this case, we do have things being multiplied, 25 times x cubed. So let's go ahead and write those as 2 individual logs being added together. In this case, you notice they are using the natural log. So the natural log of 25 plus the natural log of x cubed. Okay, next, the power rule. do I have exponents that I can bring out as multipliers? And we do. We have a 3 here. And in fact, you could even take this one further. Let's say we rewrote 25 as 5 squared. And I think we can actually take that exponent out as well. So that was nice that 25 happened to be a perfect power that would give us another exponent that maybe we could pull out. So let's take this one as far as we can. Well, that means we can take this 2 out in front of our logarithm, and we're going to get 2 times the natural log of 5. Same thing with that 3. We're going to bring this 3 out, and that's going to become 3 times the natural log of x. And of course, these are still being added together. There's our operation between them. And there we go. This is what we get. That is as fully expanded out as we can make this. There was no quotient rule. We did the product rule. We separate them as 2 logs being added together. We happen to notice that this was 5 squared. Okay, that's not going to happen too often. And then if we do have exponents, in the end, we can bring them out as multipliers. Okay, let's try example 2. Just going to step it up a little bit. This time, we do need to use the quotient rule. So again, the quotient rule says if I have things being divided, we can write them as 2 logs with subtraction between them. So let's start off with that. The natural log of the top, so we write everything in the top, x squared y cubed, minus the natural log of the bottom, which was just e. Okay, so we did the quotient rule. Next, let's see the product rule. Do we have things being multiplied? And yes, we do. This logarithm we can split into 2 logs, right? This one says we can write them as 2 logs being added. So the natural log of x squared plus the natural log of y cubed, and then we still have our minus the natural log of e. Lastly, we have the power rule. Do we have any exponents that we can bring out as multipliers? And yeah, we have a couple. We've got a 2 and a 3. And again, let's bring those both out as multipliers. So we're going to have 2 times that log, 3 times that log. And we get 2 times the natural log of x plus 3 times the natural log of y minus, and then check this out, the natural log of e. We talked about that earlier. That actually has a value of 1. So we can actually replace that with 1. And there we go. This is as fully expanded out as we can do in our second example. All right, let's try a third one. Okay, so we've got our properties and stuff over here again. So once again, first thing we need to do is the quotient rule. We do have things being divided. So let's write those as 2 logs with subtraction between them. So minus log of the bottom. In this case, we're doing log base 10, that common log. Okay, next we would want to do the product rule. So we did quotient rule, the product rule, which says if we have multiplication, which we do in 2 places, we can write those as logs being added. So log of 7 plus log of x squared. Now here, though, we need to be careful. It's minus this whole logarithm, and we're about to expand that into 2 logs being added. So we need to make sure kind of that this minus sign will apply to both, and we're going to do that by adding a grouping symbol like we just did here, like brackets or another set of parentheses. But now we can separate this log of 2 plus log of y, and this is kind of an advanced example here. Last thing to do is try to bring out any exponents. I only see 1 here that we can bring out, and we'll have our final answer. This would be log of 7 plus 2 times log of x. I know I didn't write it in green, sorry. And if you want, you can leave this with the brackets here, that would be fine, or you can even distribute the negative sign and just make them both look negative. So it just depends, on how a multiple choice answer would look, but this thing expands out pretty far. Very, very unsimplified there. Okay, next let's figure out how to do this backwards. How do we condense instead of expand? Which seems more logical, right? Wouldn't I want to condense it or simplify it? But this is kind of just working with our properties backwards and forwards. So let's try condensing. So now we're going to do these backwards. We want to do the power rule first. And it says if I have something with a multiplier, that we can bring that in as an exponent. Okay, and that's the first thing we're going to look for in all of these. So here we do have a 2 that we're going to bring in as an exponent on x. So we get log of x squared. Okay, plus log of y. Okay, our next one. Now we need to do the product rule. Do I have logs being added? Yep, and that says that we can write them as one log and multiply the inside. So x squared times y. And the last one would have been the quotient rule. Do we have any subtraction of logs? No, I'm pretty sure we've simplified this all the way down to 1 log, and that was our goal. Perfect. Okay, let's try this next one. What about here? Again, we have we're doing the power rule first. So we're going to bring this 3 in as a power of 2. So that's going to become 2 to the 3rd power. Which, because it's a number and not a variable this time, we can actually evaluate. That's going to become 8. So I know I'm probably writing an excessive number of lines here, but that's going to become 8. Now let's go through and do the product rule. We do have 2 logs being added. And the product rule says we can write that as 1 if we multiply their insides. So 6 times 8, which we'll go ahead and simplify to 48. Okay, next is the quotient rule, which says if we have logs being subtracted, we can write them as a fraction inside my logarithm in the order of the top minus the bottom. And in fact, 48 divided by 3 goes in there perfectly. This all narrows down to log of 16. Much simpler looking thing to look at. Okay, our next one here, let's go ahead and simplify inside of our parentheses. We're going to bring our 2 in as an exponent and our 3 in as an exponent. We're using the power rule there. So this is minus the natural log of y squared plus the natural log of 2 cubed, which actually we just did, right? That becomes 8. 2 times 2 times 2. So next up, again, we're kind of just going to simplify in our parentheses. We can go ahead and turn that into an 8. And because they're being added, we're going to multiply these two values. So it's going to be 8 times y squared. Natural log of 8y squared. And at this point, we really don't even need the brackets anymore since there's only one term in there. And I think the last thing we're going to be able to do here is a quotient rule. So we have subtraction of 2 logarithms. We can write them as a single log with that fraction inside in the order of the top minus the bottom. So 8y squared goes in the bottom. Sometimes that fraction in there can be reduced. So we would always try to see if we can maybe reduce our fraction, but this time we can't. Okay, that's it for the video examples. We'll do lots more examples in class. Make sure you ask questions if you have any.